Good morning, good afternoon, or good evening, depending on when you're watching this. Now today we're going to look at the difference of two waves, and we can use the same method for an expression written as a difference of waves. So let's look through this example. Express f of x equals 4 cos x minus 3 sin x in the form k cos x minus alpha. Now all the things I said before still hold true. Really important that you don't throw marks away. This is exactly how the exam board want you to set it out. You begin by making them equal to one another. 4 cos x minus 3 sin x is equal to k cos x minus alpha. Then the next important thing they want you to do is to use your expansion. So they do expect to see k cos x cos alpha plus k sin x sin alpha. That's just using your cosine expansion. So we've got 4 cos x minus 3 sin x equals k cos x cos alpha plus k sin x sin alpha. Now you identify cos x there, and I've highlighted in yellow the coefficient of that would be 4. And again I've highlighted what would be the coefficient on the right hand side. So can you see that k cos alpha is equal to 4? Now I put a green line under sin x and matched these up. So are you okay with the fact that lifting that off, we've got plus k sin alpha? Now we don't write plus at the start of a sentence if it's positive. So k sin alpha equals negative 3. Absolutely the exam board expect to see that written down. After which you would write k is equal to the square root of 4 squared plus negative 3 squared, square root of 25, which is 5. So that's us found k. The next thing we have to do is to find alpha, and we do that in exactly the same way as well. We write down k sin alpha over k cos alpha, and we know that k sin alpha is equal to negative 3, k cos alpha is equal to 4, and as before we're going to cancel that off. So we have sin alpha over cos alpha, which we know is tan alpha. So tan alpha is equal to negative 3/4. Now, we've got a decision to make. Which quadrant does alpha lie in? In the example where we were adding waves, we didn't have that decision. They were all positive. So we're going to go back here to our k cos x. K cos alpha equals 4. K cos alpha is equal to 4. Now k is positive. So if cos alpha is positive, what I would want you to do is tick on your diagram. If cosine is positive, where would you expect your answers to come from? If the cosine is positive, you would expect an answer in there or in there. Then we're going to look at the k sin x equals negative 3. Again, the k is positive. Where is the sign negative? Which two quadrants would you expect your answer to be in if the sign was negative? It would be there and there. So the quadrant that's got the 2 ticks, that's the quadrant we're looking for, the 4th quadrant. And that makes sense because the sine is negative, the cosine is positive, and the tan is negative. So that quadrant that fits the bill there is the 4th quadrant. So we're solving this trig equation, and it's exactly the same as you did in Nat 5. We're going to first of all solve tan alpha is equal to 3/4 to get our answer in the first quadrant. So alpha would be the inverse tan of 3 divided by 4, exactly as you would do in Nat 5. So alpha, if you put that into your calculator, you would get alpha is equal to 36.9. Now that's not our answer, that's the answer in this quadrant, 36.9, and we know we want it in here, so it would be 360 minus 36.9. So that would give us 323.1. 323.1. So that is our answer there in the 4th quadrant. So alpha is equal to 323.1 degrees. So we're going to go back and finish off. We had 4 cos x minus 3 sin x is equal to k cos x minus alpha. And we've found these values now. So 4 cos x minus 3 sin x is equal to k, which we found to be 5, cos x minus alpha, x minus 323.1 degrees. Okay, so let's try a second example. This time we've got root 3 cos x minus sin x in the form k cos x minus alpha, but alpha this time lies between 0 and 2 pi. So we've got an example in radian measure. Apart from that, it's the same type of example. So I've gone through it again, k cos x minus alpha, make them equal to one another, again use your expansion, and again pick out the values. Coefficient here is root 3, here is k cos alpha equals root 3, k sin alpha equals negative root 1, and we can work out k. From there, once you've done these lines, k is equal to 2, following the way we've got it set out here. Then again, we would try to find alpha. So again, we write k sin alpha over k cos alpha. And we've got k sin alpha is negative 1 and k cos alpha root 3. Again, we cancel these off. And again, that's tan alpha. So there really is a method here. You'll be falling asleep. No, don't fall asleep. You need your wits about you. So negative 1 upon root 3. So we've got tan alpha is negative 1 upon root 3. Got to decide which quadrants alpha is in. So again, k cos alpha is root 3. Where is the cosine positive? The cosine is positive in here and in here. Back over here, sine alpha is negative 1. So if sine is negative, which quadrants would it lie in? In here and in here. So again, that tells us it is the fourth quadrant our answer lies in. Now this actually could be done without a calculator. Remember, you need to know these exact values. This could be in a paper 1 and you do not have access to your calculator. Now if we were looking at in the first quadrant, tan alpha would be positive, 1 over root 3. So tan alpha is equal to 1 upon root 3. Now it is an exact value. You should know that the tan of 30 is equal to 1 upon root 3. Now it's radian measure we're in, so 30 is pi by 6 or 1/6 pi. Now that would be our answer in the first quadrant. That's not pi by 6, I'm going to write as 1/6 pi. It's not that we want, our answer is in here. So that's 2 pi minus 1/6 pi. So we're going to write that 2 as 12 over 6. Still 2 pi, but 12 over 6 pi minus 1/6. You could actually do this in your calculator. If it was paper 2, you could just put 2 minus 1/6. So that would be 11 over 6 pi. So that's us got the value there. So we found k and we found alpha. Let's write that out now. We had root 3 cos x minus sin x is equal to k cos x minus alpha. And we found k and we found alpha. So root 3 cos x minus sin x is equal to, k is equal to 2. So 2 cos x minus 11 upon 6 pi. Thank you.